Okay, so I have one last thing for today, just because I wanted to. Um, so basically, let's say we have this cubic function right here, x to the 3 plus 3x to the 2 minus 6x minus 18. So I actually already have this plotted out, and we have x-intercepts at minus 3, minus 2.44, and then positive 2.44. So you might be confused because I already just gave you the roots, which are the answer, but let me show you how you can find these algebraically. So one thing you have to be familiar with is factoring by grouping. So again, let's write this equation and set y to be equal to 0. So this equals 0. And we have to understand like terms. So a way we can do this is by splitting the equation into two groups. This group, so this x to the 3 plus 3x squared, and then this group, minus 6x minus 18. So we're going to take the like terms and stuff out of these equations and get them outside of these parentheses. So first off, you have to figure out what's in common between x to the third and positive 3x to the second. So you'll notice that there's two x values here, x to the third and x to the second. So you can actually take x to the second out. So if you take x to the second out of x to the third, you just get x. So let's take this one out of the parentheses. So we have x to the second, and now you have x plus 3. And then on this side, we actually want what's in the parentheses to match this x plus 3. So let's do this again, except we have minus 6 and minus 18. So what's in common between these? We have, if we divide 18, let's say minus 18 real quick. If we divide it by minus 6, you end up getting 3. So these have a negative in common. You can take that out. And then these also have a 3 or a 6 in common. So you can divide it by negative 6, this entire thing. And we can put this on the outside to get minus 6 parentheses x plus 3, because we took the negative out as well. And if you were to multiply this back in, it would be minus 6x minus 18. So that works out. So now we have both of these terms being equivalent. So a way you can do this is, I don't really know how to explain this very well, but you can treat these two terms just as one. So if we move this down, we can write this as x squared minus 6, taking these outside terms, and then we can multiply this by x plus 3, and we have 0. I actually can't explain this because you're multiplying, let's say x to the second, or x squared. You're multiplying this by x plus 3, and you're also multiplying minus 6 by x plus 3. So if you combine the x to the second, and you combine this with the minus 6 to make it one thing in the brackets, or in the parentheses, you can just multiply it with one of these x plus 3 terms, and you get this nice little x squared minus 6 times x plus 3. So now we have something that's a lot more familiar and a lot more comfortable. So we can take both of these separately. My computer's lagging a little bit. So this is x squared minus 6 equals 0. Then x plus 3 equals 0. So this one I've went over a million times, so now it's obvious. You can say that this equals minus 3. And then on this side, we can take positive 6 on both sides to get square root of x, or x to the second equals 6. And then you take the square root of both sides, which would get you x equals plus or minus square root of 6. So let's look at our graph again. We have the negative 3, which is what we got here. And then we got this negative 2.44 and this positive 2.44. Let's get to the precise number. You take this to the power of 2, and you get approximately 6. So the square root of 6 will be this number and its negative counterpart, which is exactly what we got here. So you could type, again, as I said with the last video, you can type this in all of these forms and you'll get the same thing. So let's take like this one, x squared minus 6 times x plus 3. Let's see, let's type this in. Make sure I'm actually typing in right, because that's important. Times x plus 3. And the graphs are right on top of each other, which means that, yes, this equation is the exact same as this one. So we just proved that you can get the roots by factoring with grouping. And I'm going to try to make that all for today. I didn't mean to take a screenshot, bruh.